Hello and welcome to the Whirly Bloke channel. Today I'll be doing a full build log of the Shendrones Squirt V2 4K HD Cinewhoop. I've been playing around with these awesome little Cinewhoops for a while now, and the HD versions like this one give you great 1080p footage, and they're small and can be flown safely around people. And in an upcoming commercial video project, I need a Cinewhoop that's capable of at least 1080p, but more importantly, much higher bit resolution and quality. So, I decided to build a Cinewhoop that's capable of carrying a GoPro Hero 7 Black and can be safely flown around soft targets, indoors and outdoors. In this full build log, I'll show you all the components I chose, as well as full details of the build. And I've based this on the Shendrones Squirt V2, which is a 160mm quad with full ducts. And although it isn't that small and light, it does have enough weight to give buttery smooth, slow flying performance without being blown around in the wind. Now, this video was originally an hour long, but I've cut this down to 20 minutes and skipped over or sped up the really obvious and boring parts. But if there's something I've skipped that you need to know, just leave a comment below and I'll do my best to answer it. And I've also put chapter links in the description so you can skip to sections that you want to. And this will be part 1 of the build, and in part 2 I'll cover the full Betaflight setup and the PID settings that I think work best for this drone. And this entire build can be easily completed in a couple of hours if you use the components that I did. Although you will need much longer if you decide to 3D print the ducts and mounts yourself. But if you print them overnight, the 3D elves will do the work while you're asleep. So let's get started. First out of the box we've got the frame. This is the Shendrones Squirt V2, which is a 160mm 3-inch ducted quad. And the ducts generate about 240 grams more thrust, so the Squirt is a pretty peppy flyer that can carry a GoPro. And they also double as prop guards, so it's safer to fly close to people. I've ordered mine without the 3D printed parts, so I'm going to print those myself. And the frame kit comes with all the hardware that you need, standoffs and bolts. Next up is the flight stack, and I've chosen this Magnum F4 Mini from Emax, which is a really nice all-in-one flight controller, ESC and VTX. In one small package that weighs about 17 grams. It's really nice. I've used it on quite a few builds and it's been really good. Comes with all the hardware you need. You get a couple of pigtails, one with a dipole, one with an SMA connector, and the connectors for your XT60. So here's the package in a bit more detail. It really is very nicely made and makes for a very neat build. It's got a BL Heli 4-in-1 ESC board on the bottom, and that's good for 35 amps continuous and 40 amp bursts, which is more than enough. And it supports D-shot, multi-shot and one-shot, which is great. There's an Omnibus F4 flight controller on the top with an OSD and a nice little VTX board on the top. It's just about everything you need, and it only weighs 17 grams. There's even an onboard buzzer, which is great. It's got the usual PPM and S-Bus inputs for the receiver, and I'll be using S-Bus. And the VTX has got 37 channels and is switchable from 25 to 200 milliwatts. And a big plus is the TBS smart audio support, so you can adjust the Betaflight settings in your OSD as well as the VTX frequency and power settings. It really is a great little package. I've used it on a few builds now. And these are the ducts and various bits of mounting hardware that I've printed out of TPU. These ducts take a long time to print. You need to print them really slow. It's about 5 to 6 hour print, this one. But they come out looking pretty good. This one's for the SMA connector at the back, and this front one I'm not so sure will fit the camera I've chosen, but we'll see. Next we've got the motors. These are the BrotherHobby Tornado T1s, 1407 3600 kV, which will quite happily run 3 or 4S. I'm going to be running 4S, and they're pretty light. They're the lightest motors I could find, 16 grams. Okay, we can start building up the frame. These are the standoffs and the bolts, M3. Nice quality. These standoffs mount inside the ducted fans that I've printed off. It's how they mount underneath. You just push them in. They're quite a tight fit, but you don't want them coming out while you're flying, that's for sure. Make sure they're pushed all the way down nice and flush, so that the fan mounting itself is flush to the frame. I just tend to tighten these up by hand initially, just to get everything in place. No need to do everything up super tight at this stage. We'll go around and tighten everything up just before we do our maiden, because we're bound to want to take it apart at some point. There we go. Okay, so let's get the motors mounted on here. The motors come supplied with the usual bolts. I like to put the prop nut on there just so I'm not going to lose it. Okay, let's get these sorted out. Now watch out on these because the bolts are reasonably short. There we go. I need length on those leads. I'm going to chop those off in a minute. It's got all 4 motors on. Wires all over the place as usual. So the flight stack comes with 4 M2 nylon bolts to screw the flight controller stack to the frame. This is the great thing about using an all-in-one stack, just much easier. Less wiring, much neater, and I haven't had one blow up yet. This Emax Magnum V2 with its omnibus flight controller, I found really good. I've used it on quite a few builds now. There we go, they're all screwed in. We'll nip them up nice and tight once the build is finished, but for now they just need to be tight enough that nothing's going to fall apart. So let's get the battery connector on and the XT60, just tin these up. You'll need a hotter iron for this. And what's quite nice with this Emax all-in-one solution is they supply everything. The XT60, some heat shrink, cables. When you connect these up, double check that you've got them the right way around. Otherwise that will spoil your day. I've mounted this flight stack 90 degrees around from the direction it's supposed to be, but that's because I wanted the power cables coming out the back and easy access to the USB connector. And there's a link at the top of the page to a video I did showing you how to change the resource mapping in Betaflight, so everything's the right way around. That's sorted. We can start trimming these wires down and getting them soldered onto the ESC board at the bottom. Just trim them down to the right length, snip them off, strip the wire back, tin it and solder it all up. All pretty straightforward. And you can just repeat this for the other 4 motors. There we go, that's got the last one connected up, looking pretty neat. Again, make sure there are no solder bridges across any of these wires. And you can clean the board up with a bit of isopropyl alcohol and a toothbrush, just to make sure. And I think we'll just put some tape around these cables. Now that's got all those taped up and neatly secured to the frame. And because the wires are on the top of the frame, I'm going to need to cut out a small section of the duct just so that it doesn't bend the bottom of the ducted fan here. I've marked it up, just slice it out with a sharp knife, scalpel, X-Acto, whatever you've got. Next we need to get the camera fitted, and I'm using this Caddx Turbo EOS 2, mainly because it's small and it's extremely light. Let's have a quick look and see what it weighs. Let's just grab the scales, and that's just a shade under 4 grams. And I've used these on quite a few builds and they're pretty good. Now, as I suspected, the mount that comes as standard available on Thingiverse is just too big for this camera. So I've designed these mounts that just slip over the top of the frame here. And I'll leave links in the description where you can download the STL files for these from Thingiverse. So next thing we need to do is connect the camera up. Now I've decided to put an inline JST connector between the camera and the board. That means I can easily swap it out for something else if I want to. There's just 3 connections on the board, 5 volts, ground and signal. And that's a great thing about these all-in-one stacks. You don't need the PDB like you used to in the good old days. Everything's taken care of. There's a voltage regulator or back on the board which provides the 5 volts for the camera. Again, when you're soldering these, double check against the manual that comes with the flight controller. It is silk screened onto the PCB. It's always worth double checking. Last thing you want to do is blow the camera up. Again, make sure there's no solder bridges across those connections. And we can tidy that away and get the camera mounted. And you can simply fix this to the mounts using the bolts that are supplied with the camera kit. And this just pushes down onto the front 2 standoffs on the frame. It's a little bit tight, but it'll go. Let's get the camera connected up. Looking good, give a tight squeeze. Right, so next on the list we've got to get the receiver connected, and I'm using an FrSky XSRM. Now I would have normally used an XM Plus on this because the stack itself is really designed to take an XM Plus. I've had them on order for a while and they still haven't turned up, so we'll use this for now, which will be fine. But if it turns up, I'll just take this one out and put the XM Plus in. Now the way I like to mount the receiver antennas is really simple. It's what I do on all my quads. Just use a tie wrap and then you can stretch the antenna around the tie wrap and put a piece of heat shrink around it. Keeps them well out of the way of the props, and it's really cheap and simple. Perfect. Just cut the end of the tie wrap to the right length and then you can pull the receiver wires around to where you want them. So you can just thread the antennas out through the back. Be careful with the exposed parts because that's the important part. Then we can just put a piece of heat shrink cut to the right length, and this will protect the antennas in a crash. Keeps them well out of the way. You don't need any fancy TPU mounts or anything like that to do this. This is just the easiest way to do it. So I've turned the SMA receiver mount the other way around because my pigtail's a little bit short. I'll probably design another one that fits a bit better. And one thing I've noticed, there's no strain relief on the battery connector, so I'm going to drill a couple of holes for a tie wrap. As if by magic, the holes have appeared, so we can get a tie wrap in here to hold those wires in place. One of the reasons I wanted to mount the flight controller stack 90 degrees from where it should be, so I could easily get to the USB connector on the back when the ducts are screwed down, otherwise it would be really difficult to get to. There we go, that's all starting to look pretty good. Quite nice. Okay, so let's trial fit the ducts. They just push on again, make sure that they're flush with the top of the standoffs. And the ducts are just held in place with 3 M3 bolts. Don't do these up too tight. The middle one's okay, but if you do them up tight, it tends to distort the shape of the duct, so it's not round any longer, and the props will catch. They don't need to be too tight. If you want to, just add a bit of thread lock, but to be honest, I found it didn't really need it. That looks pretty neat. Let's just get the other one on. I love the look of this thing. It's great. We should be able to just mount the top plate now. Now those front 2 bolts are also going to hold the GoPro mount on, but we don't need that on for the minute. Now we can get the VTX antenna in. I'm using this Lumineer Axi stubby, which is nice and strong and doesn't actually take up a lot of room. Just kept out of the way and hidden between the ducts. I think that's looking pretty sharp now. Next we need to get some props cut. Now I'm using these KINGKONG 4x4x6s from HK Thunder, apparently unbreakable. I've tried 3 and 4 props on my previous builds, and I think these are going to be a little bit quieter, but there's more blades to cut, so we'll see. As you can see here, they just need cutting down by quite a bit, because this is a 3-inch quad. Now I've made up these plates which are exactly the same diameter as the inside of the duct. I've just cut them from Delrin on my laser cutter, but you could 3D print them. I'll leave some links to where the drawings and the AI files are for these. The other good thing about making these discs is that you can make sure that your duct is actually round. And this is where you find if you do the bolts up underneath, it will twist it. But you can apply a little bit of heat with a heat gun if you want to reshape these. I'm going to cut them with about a 1.5 mil, 1 to 1.5 mil gap between the blade and the edge of the duct. If you make them too close, it just scrapes. Now the reason I cut 2 of these is that it means I can put the prop between them like a sandwich with an M5 bolt down the middle, and it makes a nice template for cutting off the edge. Now what I like to do is cut them roughly and then sand them down using a little jig that I've made and finish them off by hand. I find this gives the best results. Some of the prop cutters you can get are a little bit aggressive, and you can end up with by burning the edges of the blade. I just snip them off with a pair of side cutters. This doesn't need to be too accurate, because you're going to tidy that up later. There we go, so we can take that out of the sandwich. Let's just see if it fits in the duct. It won't, because we've cut it quite roughly. But it gets in the right ballpark, and then we can actually sand those down. So this is a jig that I've made. It just screws onto my Dremel. I'm using a sanding disc, and there's a 5 mil bolt there, which I can move in and out, but I've got it adjusted so that it is exactly the right distance. You can just loosen this bolt off and move it around. It's not exact, but it's very easy to see whether you've got it right or not by using the disc. Here we go. Nice and gentle, you don't need to be too aggressive with it. And the bolt is there just to keep it perpendicular with the sanding disc. The other prop cutters that I've seen which are using a cutting bit can be quite aggressive on the edge of the props. And particularly with these so-called unbreakable props, it can actually shatter the edges. So that all looks good. You just need to trim off the excess flash that you get. The bits of flash just come off by hand, you can peel those off, and then you can tidy them up with a piece of sandpaper. You just don't want any rough edges, don't go mad doing this. Okay, there we go, one prop done. And that should nicely drop onto the spindle and be an even distance all the way around. That looks good. There we go, all 6 props done. Now if you look carefully, the receiver which I mounted on the front has gone, And that's because just after I soldered everything up, courier knocked on the door and my back order of FR Sky XM Pluses turned up, and that solders quite neatly onto the stack here using 3 little standoffs. It's a much neater solution and mechanically a lot better than using that double-sided foam. It's what the Magnum F4 Mini was designed to take, and I think there is actually a version that you can get from Banggood that includes that already mounted up. It's great. Antennas out the way, push that plug out the way. Right, we're getting pretty close to the end here, so let's get the last of these bolts in. So how many times have these been in and out? I've pretty much forgotten, I must admit. I think that's looking great. We just need to get this top plate on. And here's the GoPro mount, which just screws on with the front 2 bolts. Now I'm hoping that the angle of this GoPro is right. It's pretty much just about 1 or 2 degrees. And the FPV camera, I'll probably run at about 10 degrees, something like that. We're not going to be flying fast with this. We're going to be flying low and slow. So we want the angle to be nice and shallow. There we go, that looks great. And one of the things I like about this GoPro mount particularly is it means that I can get some ND filters on the front without having to make up a special mount. For the sort of cinematic footage that we're hoping to get, ND filters will make a huge difference. It introduces a bit of motion blur, which is exactly what you want. Let's see what this weighs. It's not a light build, but that's completely deliberate. 374 grams. Now this isn't a light build. It's not intended to be. Trying to make this under 250 grams would never work. But we want something that's got a bit of weight behind it because we're going to be flying slow and smoothly. In part 2, I'll be covering my full Betaflight setup. I'll see you next time.